Hey all, welcome back. So, in the previous sessions, while we are talking about constraints, we have already talked about different types of constraints, like what is important in constraints, why are constraints very important in system Verilog, and what are different kinds of constraints. So, we have already talked about if else and conditional statements, how we will be writing if else and conditional statement within our constraint. Okay, so in today's session we are going to talk about some other constraints also, and before going into this I am already explaining you that constraints is very important within system Verilog. So if you are someone who are entering into interviews or else who are writing some written tests related to the system Verilog, okay, you can expect more than two questions from these constraints, because like constraints, assertions, coverage, these are something that you will be using in your real time. Like when you are developing some test bench structure, you will be obviously writing these things within your code. So that is why constraints is really important. So I have already uploaded two videos on this constraint. I link that in the description box. You can go there and check it out. And coming to today's session, which is implication operator. So we will be using some type of operator in our constraint, which is implication operator. So it will be denoted by arrow symbol. If you see here, this is how you will be writing the implication operator. So the syntax for that is expression, okay, implication operator constraint. That means how this will be working is, okay, so you will be, if you see the code here, you are writing the constraint here. So constraint, the name of the constraint, and within the braces you will be writing the implication operator. Okay, how this implication operator works means, okay, if the expression is true, then the constraint will be executed. If the expression is false, then the constraint won't be executed. That means if you see here, if scale is low, okay, this is my expression, that means this is my condition. If scale will be low, then my constraint will be executed. If the scale is not low, then this particular condition is not being executed. So how is this going to work? If you see this, the remaining everything I am not going to explain because you already know it. Okay, so here this particular randomization I have executed for 5 times. So in all these 5 times, if you see, my scale is low for only one time. The remaining 4 times my scale is high. So that means the remaining 4 times this particular expression is false. So since this particular expression is false, this particular constraint won't be executed. That means the value, if you see here, if this is true, then the value should be less than 50. But since this is not true, the value is always greater than 50. But if you see the last execution, the constraint, the expression is true. That means the scale is low here. So that is why the value is less than 50. Got my point? So this is how you will be using the implication operator within the constraint. Right? So now coming to, this is about the implication operator within constraint. Okay, now coming to the next one, which is this keyword. Okay, so basically this is also type of constraints. So why is this constraint used within our system Verilog is that basically you are having two types of constraints within this, two kinds of disk keywords. One is by using colon, okay, slash symbol, and another is colon equal to symbol. So basically constraint is nothing but, what is constraint? We have already know that constraint is nothing but putting limitation to our randomized value. Is it or not? We are randomizing the value, and for that randomized value, when you want to put the limitation, you will be putting that particular limitation by using the constraint. Is it or not? So basically, in this limitation also, for example, okay, let me give you some example here. You are randomizing some 1 to 10 numbers. Let us consider. Okay, that means you are randomizing the values between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the numbers. Within these numbers, you are randomizing particular bit. Okay, so while randomizing this, how can you expect that how many times you can expect that the 3 can be coming. For example, if you are randomizing this for some particular 5 number of times, that means you are repeating the randomization for 5 times. So within this 5 times, what is the probability that the 3 comes for some 2 number of times or 3 number of times? Is there any, yes, is this nothing but probability of coming? Because as we told you, will be designing the complex designs. So when we are designing the complex designs, okay, obviously we need higher amount of bits. Like for example, we will be designing the circuits when they are complex in nature. Obviously the bit storage will also be high. So in that, among the bits, when you are randomizing a particular variable which is having high bit value, then among that, how many times you could expect that particular value will be come? What is the probability that you require this particular number will be given for some 2, will be coming for some 2 number of times, some 3 number of times, is it or not? So in order to increase this probability, that means in simple words, when you are randomizing some 1 to 10 values, what is the probability that 3 will be coming for 3 number of times? Okay, but while we are just randomizing it by putting some constraints, we can't expect this. Okay, when you want 3 to come for 3 number of times, okay, you should put some more limitation on it so that your 3 will be coming for 3 number of times. Okay, so for that you are using this keyword. This keyword is nothing but weighted distribution during randomization. Weighted distribution means how many times that particular number will be existing in your randomization. While you are randomizing for 10 number of times, how many times the 3 will be coming? Okay, so that is the weighted distribution. So for that you will be using two kinds of weighted distributions, which is colon hash colon equal to. So let us see how these two will be working. For example, let me give you a small example so that you will be easily understood about this keyword. Okay, if you see here, constraint value C. Okay, so my value this is my particular. So 3 semicolon hash 4, and here if you see here, this 3 is nothing but the value. Okay, this 4 is weighted distribution. Okay, so what is this? That means for among the values that you are being randomized, the 3 is the value that you are expecting it to be for 4 number of times. Okay, the 3 will be coming for 4 number. 3 means it's a value, it's a number 3. 4 is nothing but weighted distribution. That means the number of times the 4 will be existing during your randomization. Okay, here this can be either the value or in the within the range also. Now if you see here, this is within the range. That means 5 down to 8. So you can expect 5, 6, 7, 8. So all this 5, 6, 7, 8 will be having this 7 weighted distribution. Now what is the difference between slash and equal to is that, okay, if you are using only one value, then there won't be much difference between slash and equal to. Both are same. But if you are using a range, like 5 down to 0 means it is a range which is having 5, 6, 7, 8 values. Okay, when you are using slash here, then what happens? So these 4 values will be distributing this weighted distribution. That means here 5, 6, 7, 8 will have the execution. Like when you are giving 3, 3 will be coming for 4 number of times. But when you are using the slash for within the range, then the 5 will be distributing the weightage. That means how many values, what is the weightage here? 7. And how many values are there? 5, 6, 7, 8. So 7 divided by 4, 1.75, which is approximately 2. That means the probability the 5 can be coming is for 2 times. The probability that you can expect 6 is for 2 times. The probability that you can expect 7 is also for 2 times. Similarly 8 is also for 2 times. But here if you see here, the probability that you could expect 3 is for 4 number of times you can expect 3. Okay, so that is the thing for slash. Okay, when you are seeing the same for when you are using the same distribution with equal to, then that means, just like I told you before, when you are using this one value, one single value, then there won't be much difference here. If you see here, both are same, but when you are using the range, then what happens here, there won't be any distribution. That means all 5 6 7 8 values, the probability of their existence in your randomization is for 7 times only. That means there won't be any sharing, because if you are using slash, you will be sharing the distribution within the range. But when you are using the equal to, even though it is within the range or single value also, everything will be having the same weightage. That means the weightage, the probability that particular value could exist during your randomization is very more compared to the others. Okay, if you are still don't understand about this keyword, for simple understanding I will tell you. Okay, when you see the MCET rankings and all, okay, during MCET ranking, during allotment of seats and all, okay, so the along with the rank you get, there are some other things that will increase your probability of getting a college, is it or not? So basically, in this way, similarly, along with the constraints that you are using, if you want to put more weightage on it, that means if you want to put more priority on that particular value, then you will be using this dist keyword. Got my point? So this is about the dist keyword. So for this dist keyword, you will be using two kinds, which is this and this. Okay, that is colon slash and colon equal to. Clear? So this is about the implication operator, whereas distance keyword within your system Verilog. Okay, within your constraint. So this is another kind. If you see here, since this is equal to, so that is why 2 will be coming for 5 number of times. You could expect 2 for 5 number of times. Similarly, 10 11 12 can also come for 8 number of times. Okay, but if you are using the same with slash, then since it is single, then there won't be any difference between the equal to and slash. But if you are using the range, then what happens? Both 10 11 12, since there are three values and the weightage is 8, so 8 divided by 3. So how much is 8 divided by 3? Those many number of times, approximately, like if you see here, some 3 number of times it will be existing. Okay, so this is the difference between the equal to as well as slash symbol. So this is the example for that. Okay, you can just execute this on the EDA playground. So basically, as I told you, I'll be uploading these particular slides on my uh, uh, Telegram channel, so you can go there, download there, and you can copy this particular program and execute on the EDA playground, so that you can understand what is the difference between equal to and slash. Okay, and if you are still having any doubts after executing that on the EDA playground, you can ping me in the comment box. Right, so this is about the implication operator and this keyword within the constraints. And then the next one is inheritance within constraints. That means here, if you see the inheritance within the constraint, how we are you going to use the constraint with inheritance. Okay, so this we are going to explain it. If you see the code here, okay, here this is my parent class. Okay, where I'm using one bit. Okay, that is value, which is 5 down to 0. Now I'm writing the constraint within this parent class. So what is my constraint? Okay, constraint value c. Okay, here if you see, value is greater than 0, that means greater than 0 means 1 2 3 so on. Okay, and along with that, I'm giving the limitation like value should be less than 10. Value is greater than 0, less than 10. Then what are the values? 1 2 3 4 5 6 7 8 9 10. That's it, right? So this is the thing for inheritance. This is my constraint for my parent class. Now end class, again I am taking another child class, okay, which is extending from parent class, within which I am just overwriting the constraint here. If you see here, I am writing with the same value. See here. Okay, this is my constraint value. See, this is Now, if you see here, this is called overriding of constraint within the inheritance property. Okay, so basically, why do you use inheritance in order to override something from the parent class? Because as you all know that inheritance, the property of inheritance is that everything that is present in parent class, you can take that into your child class. So by using this, what I am doing, I am just overriding the properties of my parent class, which is the constraint also belong to that particular parent class. I can override that also. So value c, which is value inside 10 down to 30. So okay, here if you see value inside, I have already explained this value inside, what is inside and what is these things in my first class of constraints itself. I already told you, I link that in the description box, you can go there and check it out. Okay, so now what will be the values? 10 down to 30 means 10, 11, 12, so on up to 30. So if you see here, this is entirely opposite. So it is from 1 to 10 and it is from 10 to 30. So I am changing from 1 to 10 to 10 to 30. Now n class, okay, module, parent and child. I am taking two handles, parent as well as child. Okay, I am now creating two news for both my parent and child, and I am repeating this particular randomization for three number of times. So what is the randomization here? P dot randomize. That means with the parent handle I am randomizing it, and similarly with the child handle I am going to randomize it, and I am going to pass the values for P value and C value. Okay, so what are you thinking the outputs will be? Okay, so I'm not going to answer this particular question. Okay, if you are interested, you can just execute this program on the EDA program, or you can just estimate the code and you can just give me the answers in the comment box. I will tell you whether your answer is correct or not if you are going to ping me in the comment box. Okay, but do try to answer it, right? So do try to estimate what will be the output when you are doing a P dot randomize and when you are doing it with C dot randomize. That means when you are randomizing with parent handle, what is the randomization output? What is the P value? Okay, similarly when you are randomizing with child class, what is the C value? Okay, because as I already told you, we are using the inheritance property here. So try to estimate the output and ping me in the comment box. If you are correct, I will definitely answer your answer. If you are wrong also, I am definitely going to answer why you are wrong in this particular case. Right? So this is about the inheritance within constraint. That means how we are you going to use the constraint within the inherited class. Okay, so this is about the inheritance. Now next coming to function inside the constraint. Okay, so I'll explain this in the next class. You can just take the snap of it and you can just check this out also if you are interested. Okay, so that is all for today. If you are new to this channel, I'm a design and verification trainer who will be explaining concepts on design and verification domain courses like Verilog, System Verilog, UVM and some protocols. Okay, so if you are new, please consider subscribing this channel and also please share it to all the VLSA enthusiasts who also wanted to enter into design and verification domain. That is all for today. Thank you.